Hello, good morning to all of you. Am I audible, Angad?
Yes, Ankur, you are audible. You can proceed.
Okay. Thank you. Thank you for your confirmation. Okay. So I hope you all are doing great. So our today's agenda is fundamentals of CAM processes. Before proceeding further, let me introduce myself. Ankur Sharma. I work as a senior application engineer in 3D Works Design Solutions. So what do I do? Providing solutions benchmark on the principle of offering solutions that ultimately improve the overall profitability of manufacturing processes, which results in saving timing. So I successfully implemented CAD/CAM systems and DNC optical isolator for OEMs like Sonalika, A1 Cycle, Hero Group, and many more. Uh, Before proceeding further, let me introduce the specific safety precautions before implement any operation in CNC section, even it is turning, milling 3+2 or 3+1. The first one is always wear your safety gloves, shoes and glasses. Secure loose clothing that could become caught or tangled in the moving parts of machine. Clamp all work securely before starting machine and make sure that your door is always closed. Prepare and review your program carefully, even in G code or M code, safety codes also. You can take a dry run test before. Dry run means you can take a offset 50 mm above or 10 mm above to make sure that your program is running correctly. And last one is press the cycle button for machining to begin. Stop the machine immediately if you notice any irregularity. In all emergency situations, always push emergency button. So our today's agenda is manufacturing. What is the manufacturing challenges the industry face with manual programming and the about CAM system. After that, we will talk about stock cutter selection, cutting toolpath strategies, NC parameters, cusp height. And at the end of presentation, I will show it on the our CAM system also. So what is manufacturing challenges? Most common challenges when we not use any of CAM system, when we doing a manual programming. The points is that machining time prediction. Like when we are going to make a program, we have to take a dry run test in our machine. It includes our like we have to engage our machine for several times, operator, programmer, coolant, and tool also. So in manual programming, we are not able to judge our timing. What is our time? So that we are not able to generate a code for our customer. In CAM solution, in vacancy or solid CAM, we can know our time in advance after implement the G code M code creations. And after that, in manual programming, suppose you are going to create a program from your stock like casting or forging. There is no more accuracy than our CAM system in the manual programming. In CAM system, there is more accuracy and consistency. Next is that there is there any need to enter or modify manual code. In manual program, we have to always write safety codes, and if we have to modify our programs, like we have to cut our toolpaths below the 50 mm or 55 mm. In manual program, there is more complexity, but in CAM solution we have to only clicks 2 or 3 buttons, then our whole codes is automatically modified according to our stock. Then after that, seamless integration with CAD system. In manual programming, we are going to mirror our whole program with 2D CAD drawing. We have to select the origin coordinates. We have to after that, there is approximately 2 to 3 hours we are engaged with our manual programming. But in our CAM solutions, we also can draw our CAD, and also we can modify our CAD environment also. If suppose you have a 5-degree draft, you have to amendment it on 7-degree or 8-degree. Your radius is 2 mm, you have to modify it on 3 mm. You also can do it your CAD system. Like you have to analyze your body, where is the radius, 2 mm radius, 3 mm radius, all things. After that is collision detection. In suppose you generate your program after you can detect your collision. Collision means accidental case. Suppose you have to plug your holder above the 55 mm, but your program is for the 54 mm. Hello.
Yes,
Hello.
yes, Ankur, you are audible. You can proceed.
Am I audible?
Yes, yes, you are audible. You can proceed.
Okay. Thank you. Next one is simulation. In manual programming, we are not able to judge where our tools is running, but in CAM solutions, we can also judge where our part is run and where is not. Second last one is control on your part programming. In CAM solutions, you are able to more control on your CAM program. Last one is documentation. In manual program, you have to document with your copy or pen, or after that Excel sheet. But in CAM solutions, you are able to judge what is next tool will be run on your CAM system. So these all are the advantages of CAM solutions. So what is CAM? Business mind. Basically, the CAM is the complexity of program is by hand, like manually, certainly takes much longer as
WorkNC is an
earlier
easy-to-use
about this,
CAM software
and
geared
also
for complex
requires
3D machining.
calculation and verification, like simulation or gauging check. But in CAM software makes this much easier and doesn't require as much machining knowledge or skill. It also reduces the error involved with programming, which brings me into my next point.
The typical WorkNC customer
Based
manufactures
on that
plastic injection
definition,
molds,
you
stamping
need
dies,
3 components
patterns,
for
or
a
anything
CAM
with a
system
complicated
to
3D
function.
shape.
Software
WorkNC is
that tells the
capable of 2D
machine
milling and
how
drilling,
to make a
3
product
and
by
3 plus
generating
2
toolpaths
milling,
like
along with
G
5
code,
axis
M code,
simultaneous milling.
spindle is clockwise or anti-clockwise,
WorkNC's interface allows
and
the
where to
user
use
to
the
create
air.
reliable toolpaths with just a few
We
clicks.
all
We
can
take the
define in our
guesswork
CAM
out of
system.
programming
So
by
second one is
utilizing optimized
machinery
toolpaths that
that
work
can
off of
turn
the 3D
raw
model.
material into a finished part.
This results in
Like
less
we can
input from
also
the
define
programmer.
welding material also 2 mm, 3 mm.
WorkNC has
Last one is
first-in-class
post-processing,
collision
which is the
detection
most
capabilities.
complicated part
From tool-order
in
collision
our CAM
detection to
system or
tool-order
the
collision
manual program
avoidance
also.
to full machine
Post-process
simulation and collision
is that
detection.
which converts
This allows
tool
the
parts
user
into a
to
language
program with the
machines can
shortest tool
understand. Like
possible,
our
resulting in
Windows
faster
can
machine
understand
times
binary
and better
language
surface finish.
0110. So
All of these checks
these 3
combined
components
allow
are
the user
viewed
to be
together
confident in the
with
code they're sending to the machine.
tons of human labor and skill. As
Most CAM
we
softwares
have
on the
spent
market do
year
not
and
have toolpaths
building
designed
and
for certain
refining the
segment
best
cutters.
manufacturing machinery around.
WorkNC has
Today,
customized
there's no
strategies
design
that
to
fully
touch for
support these types of
any capable
tools in
machine is to handle.
3-axis
So
as well
we
as full
can
5-axis
draw our CAD
simultaneous
drawing
machining.
also in our CAM system. So the first step before implementing the CAM is you have to know what is your stock. Like it is a solid block, what is your block size, is it casting, is it forging, from where you have to cut it. Okay, so when it comes to 3D part programming or rely any part programming, controlling where the tool is cutting or not cutting is vastly important. This one topic in many ways determines the success or frustration you will have on your current or future project. Let's take a look some more upon it. First of all, we have to select our geometry. Geometry means the thing which you are going to cut on your machine, the final part. Before cutting the final part, you have to know your material. Like this is my solid block. My final piece is 520 into 520. Suppose after that my block will come with 600 by 600. So suppose if you already generate your all toolpaths. Then after that, in your CAM system, if you modify your block onto 600 by 600, you don't have to generate all path again. It will automatically generate your all toolpaths. Okay, so as you seen in this picture, I mentioned here 10 mm stock, here 5 mm, or here 3 mm. So it will run only those particular area only. Like suppose in forging unit, if your die is wear, then after that what forging man do in they cut their 10 to 8 material according to their wearness. They will cut all the material on your conventional machine because the inserts is costly, so they do not cut it on your VMC. So what we will do, we define all area particular 5 or 10 it will, the tool path will generate according to that part only. Okay, the third one is that we have to generate the boundaries or surface where we have to run their parts. Okay, this is the stock analyzation. So the next one is tooling selection. This is the most important topic in our programming area. So what influences the cutter selection? First of all, we have to know the material. What is our material? Like you studied in your diplomas or degrees, the workpiece material, it is basically divided into 6 different types. Each type has unique machinability and setups that make different demand on the tool, like P, M, K, S, H. P for steel, M for stainless steel, K for cast iron, N for non-ferrous, S for heat resistant, and H for hardness steel. So after that, hardness of your tool and material also. After that, features is there is a rib, is there drill, boring, 3D profile, what type of curvature is this, dimension, like you have a 100 by 100 dimension, so you can implement your 50 ball nose cutter instead of your 10 or 20 because it takes time also. Okay. Okay, so the next one is tolerance. Okay, so geometry, what is geometry selection? Like before implement any cutter, you have to analyze your profile. After that, workpiece material, as I mentioned earlier, tool materials and grades, number of cutting edges, because if the number of cutting edges is increases, then feed per tooth also increases, then your feed head will increase. So okay. So what is how many types of cutter is this in milling? First one is bull nose, ball nose, and end mill. So I basically talk about the here indexable cutter and solid carbide selection cutter area. What is indexable cutter? Indexable cutter is which is consists with the inserts, and solid carbide is end mill or ball nose. Tool comes with different grades like HSS and carbide. Carbide is more stronger than the HSS due to the material cobalt material. Okay, so what is the major difference between the indexable cutter and solid carbide? Indexable cutter is mainly using for the facing, roughing, finishing, and we can general die is approximately 12 it requires high power machines, require rigidity. In solid carbide, close tolerance precision machining, like we can use the solid carbide mainly in our finishing. After that, the tools come with maximum 25 diameter and small also. Low profile and less rigidity, fine finishing and good surface. So we have to take care of our cutter diameter, lead angle and rake angle. What do you mean by rake angle and lead angle? Like a tool come with 3 different angle, like neutral angle, positive angle and negative angle. Both have their different role. We will talk about this in our next webinar class. Okay, so what is the cutting strategies? There are 3 different types of strategies, like roughing. Roughing is which the first tool we are going to implement in our CAM system. Second one is rest roughing. Rest roughing is that the roughing does not clear their material, then rest roughing is this will clear your whole material. After that we will finish our part. Toolpath strategies. We have different types of tool strategy in CAM. 3-axis finish, 3-axis roughing, which comes with global rough, re-rough, 3-axis finishing, Z level, like Z level finishing, planar finishing, 3D profile finishing, and 2.5 axis means drilling, tangent to curve, pocketing, which doesn't consist the draft angle. After that, 5-axis machining, like 3+1 is the indexable, 3+2 is also indexable, and after that the 4-axis simultaneously and 5-axis simultaneously with come. We can do all the toolpath strategies in our CAM system, so it makes easy to program quickly. Learn about it. Next one is NC parameters. So previously in manual programming we have to convert our VC into RPM. Basically the VC is cutting speed and it is directly proportional to RPM. RPM means rotation per minute. After that we have to know about what is our Z means number of teeth, FZ means feed per tooth. Then after that we have to calculate it on feed rate. So what is the VC? VC is cutting speed, RPM, Z number of teeth, how many teeth you have, like inserts, feed per tooth. Every individual teeth have their own feed per tooth. After that, feed rate like G01, which is actually cutting the area. Rapid rate is your home position to cutting area distance. Approach rate is like you are going to define your vertical area or ramping area. It is the positioning from where the cutter will start. AE means depth of cut. Like you can define in your CAM system variable depths of cut, like 0 to 2 mm, 0.5, 2 to 10 mm, 0.2. AP is step over, like movement in XY. See, this is for example, this is a formula to calculate the VC, but in our CAM system you don't have to calculate it. See, you only have to put the value here, then it will automatically calculate your RPM. If you put your parameters wrong, then it will result into the accidental case, like your bit will broken, your edge will broken. So make sure that your all feed rates is correct. You can analyze from here: width of cut, step over, depth of cut, spindle speed. You only have, if you know your spindle speed, you only have to mention your spindle speed here, feed rate here, and approach rate here. That's it. So here is the next step: solutions to improve tool life in your CAM system. Efficiency use of cutters as per application. You have to know about what you are going to do, like you have to do boring, 3D profiling, what cutter you have to use in your tool library. You can mention all tools in your tool library. Second one is cutting tool life. Most of organization using traditional parameters. Thus the smaller dias, then the RPM will increase. If it's larger, then RPM will automatically decrease. Proper software cutting strategies for cutting tools, as I mentioned earlier. Cutting strategies like 3D finishing, 3D roughing. You have to select your cutting strategies toolpath smartly. Knowledge of cutting tools, coolant selections as per cutting data. You have to know about see, in indexable cutter, I recommend to all of you to use air compressor only, and in finishing areas you can use your coolant selections, because it's when it we comes in finishing, due to magnetic field, our hot die steel will consume all the small bursts so due to our coolant pressure, it will remove all the small bursts, so it comes in better finishing. Cutting parameters as per material. So next one is cussified. What is cussified? Like you can see these areas, the shortest distance between the tip of cusp of tool and its base plane, this is called the cusp height. The areas between the ball nose which left it. See, in previously manually we have to use this formula, under root 8 into cusp height into r, so then after that the cusp height will outcome. But in cam system you don't have to do all kind of things. It will automatically convert your cusp height into the step over. So this is my step over for the 10 mm ball nose. And finishing areas, if I put this cusp height. Okay, so we will do right now in our cam system. Wait, I will open my vacancy. If anyone have doubts, then please do let me know. Angad, please, can you please help me out from this?
Yeah, sure. Rupert. Kindly put your questions into the chat window so that we can resolve your queries in here.
You can drop your email also, so that I will catch on your email also. So this is my part which I am going to cutting. Okay, first of all I have to set my UCS. UCS means user coordinate system. I'll set it on the center. After that I have to select my geometry which I have to cut. Geometries, new selection, select the entities. After that click okay. So this is my geometry which I am going to cut here. Okay, after that I have to define the stock as I mentioned in my presentation. Like if it is a stock, a solid block, then I will click on this solid block. Simply click on a create a work zone to validate the CAD environment into the CAM environment. See, this is the CAD environment. All I am clicking on the create a work zone, so it will automatically converts it into the CAM environment. Sorry, wait a minute. Okay, I will take this part also. Okay, in manual programming we have to write this all codes manually, but our CAM system will generate automatically this. Only we have to define the tool paths and the tooling strategies like this. Our RPM tool, the method, like it is it down milling or up milling, or feed RPMs, stock allowance, tolerance, step over, depth of cut, is it running in a ramp angle or vertical, areas to ignore. Okay, so this is my stock. which I am going to cut in cylindrical shape. I defined the stock here and UCS also. Okay. So after that I am going to analyze which tool is performing here with a better efficiency. So here is a display cursor guide. I defined the tool here like 50 mm. So as I see here, it will work properly, but it will not go this rib and this rib also. So I am going to mention, I am going to roughing here, then I am going to mention my tool here, like is it ball nose, end mill, ball nose, or is it the conical ball. 50 mm diameter, 3.5. If my corner radius is 3 mm, 4 mm, then I will only have to define 4 mm here. See, is it required cooling cord, flood, mist, through tool and air also. After that I am going to mention the method here, like is it clean, conventional or mixed. You can open the help by pressing the F1 button here. After that I am going to implement the NC machine parameters, like what is my RPM. If you specify and define your cutting speed here, like my cutting speed of my 50 mm tool is 120 mm, oh sorry, 120 per minute. So I am mentioning the 120 here, and the RPM will automatically change. Number of teeth, 4. Advance per tooth, 0.013, 0.1. Okay. There is a boundary area where I have to machine my particular part. If I select this area only, it will run here only. After that I can mention my machining plane here, like where it from over surfaces and holes, like I have to machine the area over only the 20 mm. So I have to only put the value here, so it will cutting from 0 to -20 mm. After that there is the stock allowance. Stock allowance is for the next tool path, the material which is lefted by the 50 mm cutter. So what is tolerance? Tolerance is these points. The difference between the paths. This is the tolerance, point to point. If I decreases the value of the tolerance, then the finishing will improve in RA value. As you seen here is 0.1 tolerance value, and in Z level finishing I mentioned 17 microns. So let me see. So next one is the minimum width, like I can ignore my pocketing area in 7 So, what is the pocket selection? These parameters allows you to select the pocket to be machined. This function is useful for ignoring pockets which cannot be machined by the cutter you are using. Like you define the 50 cutter here, you don't have to machine over the area 75. So it will not generate the tool paths around there. We can also cutting our tool paths within few clicks. Right click on that, toolpath modification, multiple edition. Like I am going to cut this area only. See, okay, what if I only have to maintain this area and cut all our area? Only you have to click undo, invert clipping, polygon, select the areas, then right click on that. We can also define the holder here. Like I have to know what how much tool I have to hold out from the my holder. So select the tool path, click on the holder, define the holder here. Okay, cylindrical holder radius is 20 sorry 10 holder length is 50. Then after that you have to click on calculate recommended length safe only, click on OK to validate that particular command. Then see the post processor will automatically recalculate. You don't have to define over and over your pp file. It recommends me to safe length over the 36.7 So I mentioned here 25 only. See the collision where occurs.
So anyone having question up till now can put their questions in the chat box.
Is there any question, Sangat?
Not yet, but I was requesting for some questions uh, from the user side.
Okay, fine. Okay. Wait, I will take another toolpath. Okay, then please, if anyone have any questions, then please do let me know. If you have any query or want to explore more, you can call me and drop mail to me ankur at the rate 3dwds.in, or you can WhatsApp me or call me on 9875963304.
Ankur, are we done with the presentation?
Yes, Angad. Rest now. I am waiting for the audience
Question.
questions.
Okay.
Or
So anyone,
yes, sorry.
okay, anyone having question, any topic that you want,
They
that you
can,
would like?
if they have any questions, they can drop a mail to me also. I will try to clear all the doubts.
So let's since we are not getting any questions, let's proceed with
Okay.
it because we have a couple of minutes. So let's ask one by one that if they have any questions for us. So Mr. Gyan, do you have any question? Kindly let us know in the chat box. So we are still waiting for the Mr. Gyan to respond. Meanwhile, Mr. Inderjeet Singh, is there any questions from your side? Mr. Prabjot, Mr. Praveen, do you have any questions? Kindly put it in the chat box. Mr. Kailash, do you have any questions? Kindly put it in the chat window. Ankur, so it seems that there is no questions to be
Okay.
asked.
No worries.
So
Please, if you have any questions, then do mail to me on ankur at the rate 3dwds.in, or you can note down my number. I will try to resolve all your queries. We can arrange a doubt session also on the.
kindly provide us also kindly provide us feedback on this webinar.
Yes, please.
What you like, what you do not like. Kindly put it in the chat window so that we can improve and deliver you
We will
the
forward
content
you
the
the
way.
feedback format. Okay. So explore yourself also.
Okay. So thank you.
Okay. Thank you to all of you for joining today's session. Have a nice day and good learning to everyone. Thank you to all of you.
Okay. Thank you.
Okay. Bye bye.